So hopefully this actually shows up on the camera. But there's no terrible process.
Did you get a hold of the videos that I was supposed to be fixing and putting up on YouTube?
I'm not sure.
Okay.
Okay, so today we're going to be going over a bunch of different things about file systems. We're going to go over Linux software RAID, LVM, Lux, file systems, and specifically ZFS. And then my site here decided to break on my last transition, and we're also going to go over NFS and Samba. So, I'm going to kind of saunter all over this stuff fairly quickly. If you guys have any questions or you want anything live demonstrated, I have the VM running, and we can sit there and play inside the VM. But this is kind of an overview, so if you want to go into depths of something, just let me know. So Linux software RAID. RAID is a redundant array of inexpensive disks. I think there's two meanings to it, but yeah, at least two.
It's not inexpensive anymore, it's independent.
Independent disks, yeah. They changed it on me, and now I can't remember which one is which. So there's different levels of RAID, but RAID allows you to take a bunch of disks and compile them into a single pseudo disk that you can use for your system. And that pseudo disk may have redundant qualities, it may have speed qualities. You have different ways of designing that. Your general RAID levels, there's 0, which is a stripe. It's not technically RAID because it's not redundant. You have 1, which is mirror, which just takes a copy of each bit of data and drops it onto 2 disks or more, depending on your build. Yes, sir.
What's a stripe?
Okay, so the way that you can think of when the machine lays its data down, let's say that it's got 4 bits of data that it's going to put on the drive. You have a single drive that puts those 4 bits of data into a cell on the drive. All right? If you have a RAID 0, what it does is it takes 2 bits of those data and it takes the 4 bits, splits them into 2, so it has 2 and 2, and it puts half of them on one drive and half on the other drive, effectively doubling the size and doubling the write speed of the drive, but that does have a lot of limitations. Not only if you lose one drive, you lose half of your data, like not, I lost this file, I literally lost half of the bits of every file. So it's not good. You don't want to use RAID 0 unless it's data you do not care about. RAID 0 is great for things that are like, I'm running a Linux mirror, and I decide that I just want to pull the data and run this stuff, and I really don't have enough drives or money for RAID 5, and I just decide to do a RAID 0 and do thorough testing on the drives to make sure they're okay. It's data that's not unique.
And if you
download it
lose it,
somewhere
you just
else.
download it again.
Right. So RAID 0 would be used for something like that. You wouldn't want to like leave your dissertation on it. Yes, sir.
So one thing, like for the speed that he's talking about, you imagine that at least normal spinning hard drives, they have moving components, right? They're spinning, they have moving components.
It's like just doubling the number
So,
of heads.
so it doubles exactly the number of heads, so that this one's accessing the data, this one's accessing the data, so that they can work,
Yeah.
in tandem, so that to increase the speed.
So with RAID 0, when you're writing, think about it like this. You have a single drive, you have to write 4 bits of data on that drive. When you have 2 drives, and each of those 2 drives has to only write 2 bits of data, you're effectively doubling your speed because each drive has to do half the work.
Can you use more than 2 drives to really
Yes.
make it fast?
You can make 100 drives if you have a big enough stir.
Yep.
I got a
RAID
question.
1, what's that?
I got a question.
Okay.
Is it SUDO or pseudo, like, which pseudo are you talking about? Are you talking about the command pseudo?
Oh, Stripe. He was talking about Stripe.
No, before you
He's talking
said
about
it's
your
a
t-shirt.
pseudo disk.
Oh, pseudo, P-S-U-E-D-O.
Yeah.
That's what I thought. Okay,
Yeah,
I just want to make sure, because,
it's a fake disk. It's something mega
A pseudo.
amalgamation of
Right,
other things.
yeah, I got that part. I just want to make sure it wasn't SUDO.
Right. Yeah. It's a pseudo disk, as in that it's not real.
Yeah.
It's imaginary kind of. One of the things that's really cool with, you can scale these things to certain extents. You do have problems with rebuilds and stuff. So let's say I did a RAID 6, but I have 10 terabyte drives. If I did 10 terabyte drives, I wouldn't want to do a 100 drive RAID 6 because a single drive failing in a 100 drive set is fairly high ratio, and your rebuild rate is very, very long for recalculating that stripe. And I'll tell you what those do. But suffice to say, you only want to build the arrays so big before you start splitting them and doing combination RAIDs. So for RAID 1, it does a similar thing. It takes your 4 bits, and instead of splitting them and putting them on 2 disks, it puts 4 bits on one disk and 4 bits on the other disk every time. Now, there are some RAID controllers that are very smart, and they understand that they have 2 identical copies of the same data, right? And so what can happen is if you have a very nice RAID controller, you can actually have it where it's like, oh, I want this data, and it's pulling that data from one drive. And then another process says, well, I want this other data, and it uses the other drive to pull that other data. So you can effectively have double the read rate, but single write rate. And it gives you the redundancy, which is very nice. Then we have RAID 5. RAID 5 is a mathematical type. So RAID 0 and 1 are literally just splitting data and depositing them in different ways. RAID 5 actually builds calculations on the data that it deposits, and it does it across a stripe. So it builds a stripe of data across, in this case, at least 3 disks, and then RAID 6 is just 4 disks. Okay, so you have 2 stripes. You lose 1 disk of data amount per going up here. So 5, you lose, like if you have 3 drives, then you have 2 drives of space. 6, if you have 4 drives, you have 2 drives of space still. Okay. The idea is when you write data across the stripe, and then you're also writing a mathematical calculation to that data. You can reverse that calculation if you lose a disk. So 1 disk, let's say we had our 3 disks with a RAID 5. You lose 1 disk. So now you have 2 disks on a RAID 5. The data is gone off of that 1 disk. So there's actually data that's lost. But from the math that is deposited on the other disks and the data that's still left, it can figure out what data was on that other drive and rebuild it or use it.
It's a parity bit.
It's parity stripe, yeah.
Yeah, and it's basically kind of like build algebra. You do 5 plus x equals 7.
Right.
You can solve for x.
Yeah, and so you have a way of retaining that data, using it live, which is a lot less efficient than just reading it off the drive. But also, very, very importantly, you're able to rebuild that data. And so I can have a 3-disk RAID 5, lose a disk, now it's degraded, but it's still running, and then I can replace that disk, put a new disk in there, and it can rebuild the data that used to exist on that, while still using that drive, or that metadrive. Now you should replace that as soon as possible, because if you lose another disk, you're done. And reading those 2 disks to rebuild the 3rd disk is a lot of work on those drives. And so your failure rate actually goes up when you're rebuilding, because the chance for hardware failure goes up because you're using the disks a lot, and you're trying to read across the entire disk. And so you might end up burning one of those disks when you're doing the rebuild. That's why RAID 6s are great, because if you're on top of it, let's say you have that 10-disk array, right? And they're 10 terabyte disks. They're huge disks. You lose a drive, right? Well, if I replace that drive, or if I have a hot spare, and it just replaces itself immediately, then if another drive goes bad while we're rebuilding that first drive, our data is still okay, right? So if you're a corporation or something and you have a lot of data and it's important data, you want to have at least a RAID 6. Now there are RAID 2, 3, and 4, but generally those are not used or proprietary, and so we're not really going to go over those. Combo RAIDs are ways of, yes sir?
Before you get in the combo RAID,
Okay.
you mentioned something about the RAID controller. If you have a good RAID controller,
Do you want me to describe what a RAID controller is versus software RAID?
No.
Okay.
um, On modern hardware, like you buy a motherboard today, does it have a RAID controller built onto the motherboard?
Usually no.
On higher ends.
No. Those are not hardware RAID. Those are software RAID on the motherboard. Okay, so it kind of appears to be hardware RAID, but it's actually not. A hardware RAID controller is a specialized piece of hardware that is for doing those things, and a DM RAID is what usually like consumer motherboards have. Now server motherboards might have that, like an IDAC or something like that.
Super micro.
Maybe, but there is a distinction between software RAID on motherboard that it's running on the motherboard, so it's kind of hardware RAID, but they're different classes of hardware. Really, is what it comes down to. Is you have more or less enterprise hardware versus Joe Schmo chip on a board. The big difference a lot of times is if you do a motherboard RAID on like a desktop hardware and your motherboard burns out and you take those two disks and you put them onto another motherboard, unless it's exactly the same, and even it still may not be the case, unless it's the exact same motherboard, you may not be able to import your disks into that other one. And so you're just done. With software RAID, it's just on Linux, and all the metadata is on the disks, and so you can just pull those disks out, put them into something else, build the RAID over there, you're good. So the motherboard ones are not really standardized very well, and but the enterprise ones are. So like if I get like this specific enterprise one, well I can get another one, and the metadata is stored in different places, and there's recovery methods and all that kind of stuff.
Okay.
In case you're wondering, I looked up what that means. It means whoever's account that's tied to has mail.
Somebody has mail. And for those on the video, you can't see that there's a little blinking light down. So, I mystify everybody on the video down here where you can't see. So combo RAIDs. Combo RAIDs are really important in the enterprise sphere. You can do things like combining different types of RAIDs for different purposes. So like RAID 10. RAID 10 is a RAID 1 of RAID zeros. Okay, so you get redundancy from the RAID 1, and you get speed from the RAID zeros. A lot of times you use those for database commit logs and stuff. When I've done work in my previous work, when we were doing database architecture, you did like a RAID 5 or a 6 for your mainline data backend storage. You did a RAID 10 for your commit logs and your transaction logs because it's faster than RAID 6 is. RAID 6 takes time to write parity and figure out everything, whereas your RAID 10 is very quick. And speaking of RAID 6, let's say that we have very important data. Well, I might want a RAID 6 plus 1. So it's literally two RAID 6s mirrored together. All right?
So when you got all these combo RAIDs running, does that really slow down your system?
Depends on the system. Yes, it takes a lot of parity calculation and different things. A lot of times when you're talking combo RAIDs, a lot of times you're going to be dealing with hardware that is specifically engineered to do this. So it's very fast at doing the parity calculations that are needed for building the RAIDs.
Do all the disks have to be the same size?
Yes and no. Exactly. Your RAID array will be the size of the smallest disk in the array, unless you're using JBOD, which is not RAID either. JBOD is just a bunch of disks, and it literally just logically sticks the disks on top of each other. It's like a striping array, except you don't get any speed out of it. You get all of the failure rate of a stripe only, but you get none of the benefit of the speed. So don't do that. Lots of people do like doing that, but like I've never used JBODs. I don't like them. But for the size difference, okay. Let's say you have a 2 gig and a 10 gig and a 20 gig disk, okay? Well, if I make an array, I don't know how you would do it without partitions, but I would make a 2 gig partition, a 2 gig partition, and a 2 gig partition, and then I'd make my array across those partitions. So the partitions would be the same size. I don't know how mdadm would handle like you giving it multiple different sizes of disks.
Yeah.
But that's more of a design thing.
I want to say that at my last place of employment, we ran JBOD, RAID 5s, with SSDs, and it was incredibly fast.
Well, JBOD is not redundant, and it's literally just sticking material on the back of itself. So if you ran RAID 5s as the main disks of those JBODs, then you have redundancy at the 5 level and no redundancy at the JBOD level. A lot of times people will run like a 55 or like a 65 or something like that, where they have RAID 6s and then they have a RAID 5 of RAID 6s. And so like if you have 10 disk shelves, you could have like each one of those shelves is a RAID 5 or even a stripe, you RAID 0, and then you can have 6 of that. And so if you had a 60, which is also a common thing, you could have on each shelf, it would be a RAID 0. Okay, so it's a 12 disk shelf, and you have a RAID 0. So if you lose any disk, you're done on that shelf. But there's 10 shelves, and those 10 shelves, each one of those shelves is a disk and a RAID 6. And so you lose a drive, that shelf dies, now you're in parity, but you still can lose another shelf. So you replace that one disk, and then you rebuild to that previous shelf. Now you're back at your parity thing. And the 6 keeps your data safe, and the 0 keeps it fast. Now, one very important thing that I don't think I wrote on here, but I'm going to go ahead and tell you. And you're going to see this on a lot of RAID documentation and everything like this. RAID is not a backup.
What?
All right? If I go in and I delete your files out of your RAID, guess what? Your RAID's fine. But your files aren't there anymore, okay? RAID is not a backup. If your house burns down with your RAID in it, guess what? Data's gone. You lost all the disks. You know, lightning strike. Oh, sorry. You know, it's not a backup. If you have very important data on it, preferably put it, like, for a lot of us, we're just playing with it at home, put it on 2 systems. Put it on your file server, put it on your computer at home, like, you know, like your tax info or whatever, like just, you know, put it in multiple places. Back it up to a portable hard drive. Get a, like, bank vault, throw it in there. There's a lot of ways of preserving very important data.
Yeah,
Do
if
the
it's,
lightest thing, just put it on a mirror and have the rest of the world back it up for you.
So,
Right.
I was gonna say, if it's tax information, Travis will back it up for you.
Right.
Yeah. Your information, I will happily store it until you need it.
So there's a whole bunch of different things in here. Are there any more questions on that? I'll go over a kind of a quick how you build one as well.
At the end of the day, we used to have to send it to Iron Mountain so that you've got that there, and if you did fail, still you only lose what you have for the day.
Yes, but if you lose JaxLUG, then
Well,
it depends on your corporation's size and
Yeah.
scope. And
if the feds come and said, I need this data, if you hadn't got it, it'd cost you 50 times as much as it would to buy that.
Sure,
Trust
sure.
me.
But let's say that I'm a Jacksonville-based corporation.
Yeah,
Shipping my data, like, you know, plugging in an external drive, backing up to that,
yeah.
shipping it off to Iron Mountain or something,
Yeah.
fine. If Jacksonville gets hit by a Cat 5
Yeah.
and the entirety of Jacksonville just kind of sinks off into the ocean,
No.
my business is gone, so I don't really care.
Yeah.
Hopefully, I'm not here anymore, you know.
Right.
But if like I'm running a larger corporation or something like that, then I would want to have a hot site or a cold site where I'm storing my data, not in the same physical location area.
Well, that's what,
Yeah.
we work for J&J, so that's what
Sure,
we
sure.
do.
So on Debian, you would install the mdadm package, and then generally what you do, you don't want to build the RAIDs directly on the drives. You want to build them in a partition. So you make a partition, you call it, you make a typed Linux RAID auto detect, which is type FD. So I'm showing you this. This is one of the disks in the RAID that I built, and it's SDB. It's 8 gigs. It's just a little VM disk, and I made one partition that takes up the whole disk. It's 8 gigs, and its type is FD. Okay. So that's what Linux RAID auto detect. When I start Linux, if mdadm comes up, it'll actually look on the drives and be like, oh, there's a Linux RAID auto detect. What is it? And it'll try to look at it and figure out what array it is and build it on its own. If you
Are
don't
you
have
raiding a
something-
flash drive?
What?
Were you raiding a flash drive there?
I mean, maybe. It does back into a flash drive, yeah. Well, it's my SSD, but
He's got like 9, he's running a RAID 6 on 9 USB drives.
oh yeah, you can do that.
I gave
Yes.
a presentation on that.
Yeah, you can do that, and if you lose one of those drives, you know, or if one of those drives craps out on you, buy good drives if you're going to do that, because those things will just burn
They are
up.
flaky.
So we have our one partition. We did that 3 times. So I actually have SDB1, SDC1, and SDD1. I use mdadm to create my array. So mdadm create, I use verbose so I can see more material on it. The name of the device, so I just named mine devmd0, the first one. You can name it devmd, whatever. Level, that's the RAID level. So 0, 1, 5, 6, whatever, 10. RAID devices, this is the number of physical devices that are inside of this RAID array, which is 3. Now you can do fancy things where you created a RAID 5 with 4 devices, but you only give it 3 and you give it a null on one of them. So you, like, I'm saving up to buy the last one, so let me make my RAID 5, and you make it broken to start, and you just hope you don't lose the disk. You can do that. I mean, it's better to do that with a RAID 6 and then make a RAID 5 out of the RAID 6 and then upgrade it to a RAID 6, but you can grow it and do all kinds of crazy stuff. I'm not going to go over any of that. So it makes the array, it starts the array, and if I want to check the status of it, I can do mdadm detail and then the device. It gives me all kinds of good stats about it. Now when mdadm creates the device, it creates it in a degraded state, and then it grows it. So what it's doing is it's literally creating all of the metadata and everything for you. Creates it super blocks, and it creates it clean but degraded, and it recovers. So it basically builds that last disk. So its spare is rebuilding here. All right. You can tell it to create it clean, but that's a bad idea. Don't do it. All right. So you can tell it's rebuilding at 28% here, and so forth. Here, it's in the proc file system. Who's heard of the proc file system? Okay, so the proc file system is a pseudo file system. It's basically an interface to the kernel. It allows you to see and sometimes manipulate things on the kernel. In this thing, we're interacting with the kernel, asking what the metadata is, or the metadevice status is. And in this particular one, it's telling me that this thing is recovering. It's recovering at 48%. It's expecting the finish to be in 0.3 minutes. It has 3 drives, 2 of which are there, 1's gone. It also says it in this format, 3/2. It tells me what algorithm, the chunk size, the superblock level, and how fast it's doing it. After the rebuild finished, which was pretty quick because it's little 8 gig drives sitting on an SSD, you can see that RAID devices is 3, total devices is 3, superblock is consistent, and the state is clean. And down here, we have active and working devices 3, failed and spare is 0, and they're all in active sync. So that's good. We're in a good state here. For spare devices, I didn't really say anything about that. A spare device is when you build the array, let's say that I made a RAID 5 with 3 disks. Well, I can do what's called a 3+ or a 5+ 1. It wouldn't be +1, it would just be a 5 plus this 1 spare.
Is that 3 disks?
Yeah. Well, let's just say I made a RAID 5 with 3 disks and a spare. That RAID 5 would use 4 disks, but 1 would be, quote, unused. It wouldn't have data on it or anything like that. It would just be sitting there waiting. And if one of the drives went bad in that RAID 5, the meta device manager would immediately start rebuilding onto the spare. It would mark that bad drive as failed. It would take the spare in and would immediately start rebuilding onto it. So you don't have to be like sitting there watching your
I didn't get the
your
email.
RAID. Yeah, I didn't get the email, and so it's been dead for 30 months, 3 months or something. Well, it failed. It immediately started rebuilding, and then it notified you, or you noticed, and so you switch that failed disk out, and that new failed disk is now the new spare.
Can I build a RAID 5 with 4 disks?
Yeah.
Without, not a spare, but with actual,
Yeah.
okay.
You can build a RAID 5 with 20 disks.
With 40 disks, yeah, that's what I thought, I just, okay.
I don't know what there's probably limitations on it,
Yeah.
but like you're going to be getting to the point where you should build it in a different way because it's smarter to do that. Then you would probably hit the limitations of
Yeah.
the software. So,
Want to make sure.
yeah. I have ones where it's just like, I have 10 and a 6, and another 10 and a 6, and then the 2 of those are in the 0 or something like that.
Mhm.
So the 2 disks below are redundant, but the top is not, So if I wanted to stop the device, so let's say I built it, and I want to, I built it, I got a gigabit connection at my house, I downloaded like the Debian repository, and I wanted to take it over to your place or over to the stadium or whatever for something, I can pull those disks, but at first I have to stop it. So I unmount the device if it's mounted, I do mdadm stop dev md0, that stops the device, and now it's no longer mounted with the file system, now it's no longer running, now I can pull those disks, ship them off to wherever.
Yep.
Okay. If I wanted to rebuild that device, I plug those 3 drives in, mdadm, a symbol scan, it does a scan across the environment and says, oh, I see some auto
mounting.
auto detect ones. It finds them, it looks at the metadata on the disk, oh, you're partnered with this guy and this guy, let's build you together here. And it makes, in this case, dev md0.
And I've heard about some like hot swap type things. Are they doing that at a hardware level, or is that
That's more of a
something you can
hardware
do?
level, so that would be, it is the kernel level that allows that to happen. Generally the kernels are okay with that. It's more the chipset and the device interface.
Okay.
So SATA is, I believe, hot swappable. Usually you're going to have like SAS drives that are hot swappable. You're going to be looking at more of the enterprise level or the server level, where you have things that you can hot swap. Because even those, like some like HPs and stuff, have really neat things where you have a button and you can turn off a PCI lane, and you can like turn off that, pull the card, pull the new card in, turn it back on, and it's a safer way than just ripping the card out and plugging it back in, which you can do, but you gotta be real careful at which pins you get on there first. So,
And remember, lift straight up, not at an angle.
right? You gotta be real careful, or else you're gonna do spot welding things. Oh. All right. So, any questions on mdadm, RAID, or anything like that? No. Cool. LVM, Linux Volume Management. Linux Volume Management is really cool. It allows you to take a single device or partition and slice it up with a bunch of stuff, or multiple devices and put them into one thing. So let's say we had 3 RAID 5s and we wanted to do stuff across them. I could add those 3 RAID 5s to the volume group and use them as a big pool. So it allows you to support RAID-like behavior. It allows you to support encryption and other functionality, but I'm just going to kind of go over the normal stuff. So LVM has 3 distinct layers. There's physical volume, volume group, and logical volume. So the physical volume is the disk. Okay, so you could say that a partition is the physical volume. A RAID array is the physical volume. Whatever. Like you're literally taking a I/O device, a storage device, and handing it to LVM and saying, "This is yours to play with. Nobody else plays with this." Okay. It's just like putting a file system right on top of it, but it's LVM is now managing that. A volume group is a grouping of one or more physical volumes. So I can just, most of the time when I see it, it's a physical volume, a volume group, and a bunch of LVMs, or a bunch of logical volumes inside of that. So the volume group is assigned a physical volume, or multiple physical volumes. And then you can design things like, trying to do striping and fancy stuff at that level. we're not going to go over that. The logical volume is literally just taking a slice out of the volume group. So the volume group is a pool of storage. All right, so let's use our single volume. We have a drive. We have dev SDB1. Okay, partition 1 on drive B. I tell it, you're a physical volume. All right, so the physical volume is named dev SDB1. All right, cool. Make a volume group called test, and I assign it that physical volume. All right, so now that drive, let's say it's 10 gigs. It's a 10 gig physical volume. It's a 10 gig volume group. All right, now I have 10 gigs in a volume group I can play with. And so I can make a 1 gig slice and a 2 gig slice and a 3 gig slice, but I can't make more than 10 gigs of slices. So I'm literally just taking this data, this volume, slicing it up into smaller things. Think of it like partitioning on the drive. It's just that this is easier to manipulate after the fact. So like if I wanted to change the size of, say, var, and I wanted to do that on dev SDB3, well, I'm going to have to go and make changes to the, I'm going to have to remove the data, probably. I'll have to remove the data on whatever adjoining things that I'm changing, move the partitions around, rebuild the file systems or resize them, probably rebuild them, because they'd have to move the physical boundaries and stuff, and then put everything back. With this, I can say, well, var is 5 gigs, I got a 100 gig disk, and you know, this thing's making a lot more logs than I thought it was going to. So let me go ahead and grow var from 5 gigs to 10 gigs. It's easy. As long as I have the space in the volume group, I can just do it. It doesn't matter where that space comes from or anything. LVM handles that. So it's very nice for systems administration, for home users. You know, it's good to know, but you're probably going to be using it anyway, especially if you're using Ment or if you're using Ment or if you're using like Ubuntu or something. A lot of times they'll set up an LVM. Well, actually Debian will do that too.
Yeah, Debian does it especially if you do encryption, it will usually do a LUX
Encryption.
LVM.
Yeah, LUX LVM is a fantastic way, which we're actually going to go over a little bit of that. We're not going to go over how to set it up for boot, but you know, how to make one and play with it. So we're going to install the LVMto package. I want to start the LVMto daemon, but because Debian has a haphazardly built systemd, we actually had to go in and remove this file that points at dev null because it permablocks it. And it's not in the Debian wikis have always been pretty good, but since they added systemd, whoever's doing the systemd isn't talking with the people doing the documentation. So a lot of the documentation says, hey, go to etsy init.d and do this. And that it doesn't translate into systemd at all. Because they just get rid of that stuff. Or they do silly things like this, where they're pointing at the dev null and it blocks the service. So you have to remove this, and then you can start it. So you do systemctl, daemon reload, systemctl start LVMto, and then you can get the status.
The system T dumpster fire.
Yeah, it is what it is.
Great documentation.
Yeah. So now we want to make our device, our physical volume. I'm going to use the device I used before, so I built devmd0, it's a little RAID 5. All right, and so I do pv create devmd0. It says, hey, I've successfully created that, cool. Now I want you to VGDisplay devmd0, and it's going to show me what's going on in here. It's a physical volume, it's a new physical volume, that's 16 gigs. Now my disks were 8 gigs, so a RAID 5 of 3 disks is 16 gigs because you lose 1 disk in a RAID 5 of space. So 16 gigs, the PV name is this. There's no VG name, we haven't assigned it one yet. PV size is 16 gigs, and pretty much it's just sitting around being unused. All right. Now we want to create a volume group. So we use VG create. I'm going to name it VG test, and I'm going to assign it devmd0. Okay, so that's the physical volume we just did. So if I do VG display, VG test, I get information about this. Here's its name. Here's its here's its size. So 15.99 gigs, the same size as our just one physical volume. The physical extents are basically how small of chunks you can assign to different groups. So our physical extents are 4 megs. So the smallest logical volume we can make is 4 meg. And they're going to be in iterations of 4 megs. So if I want to make one that's 6 megs, too bad, it's going to be either 4 or 8. And the number of physical extents that I can assign is 4093. Now, a lot of times when I'm using LVM, you can either specify things in extents, which is this stuff, or you can specify it in size, which is this guy. I usually do size because I care more about size than I do extent. But you can do it either way. All right, and this is the UUID of that VG. Now that we have allocated that MD0 to something, I'll go ahead and do my PV display again, the thing we did at the front, and we can see that it's assigned to VG test. Okay, remember that was blank before? All right, and it was also not allocatable, these were all 0. So now we actually have values here because it's been allocated, it's being used for something. All right, now I want to create my logical volumes. I'm going to create a couple of small ones, I'm going to create a couple of 100 meg ones. And so I use LV create -n, a name, capital L. Now little l gives you extents, capital L gives you size. 100 meg, and I want you to pull out a VG test on my volume group. All right, so I made 2 of those, a test 1 and a test 2 from the same volume group. And then when I do an LV display, now notice a pattern coming up here is PV display, VG display, LV display. All these things have a very common naming scheme for the commands. It makes it easy to remember what you're trying to do. So LV display, and then I'm going to say VG test, which is my volume group, / LV test 01, which is my logical volume. It says, hey, here's your path, so that's the actual device. Here's your VG, or my LV name, my VG name, my UUID, and a whole bunch of more information about it. The size, the number of extents, logical extents it's using, number of segments, so on and so forth. And I can do that for both of them, so you can see it's pretty much exactly the same information. Now VG display, VG test, that's my volume group again. So now that I've gone and I've used part of that volume group with logical volumes, you can see that I'm using 200 meg now. I'm using 50 extents. All right, now I still have 15.79 gigs or 4043 extents available. Okay, and you can see that the number of current logical volumes, number of max logical volumes, you could actually set that if you wanted to, and so on and so forth. All right, now you can just use that, and we'll do that next. You can use this logical volume as a target for a file system or something.
All right. So you said that you're building, you've got your physical volume, you've got your volume groups, and then you've got your logical volumes on top of that.
Correct.
So once you've started building logical groups, can you add more physical volumes, or are you going to have to break it back down, start over again?
Volume groups, logical groups.
Sorry, volume
confusing. So you can add and remove logical volumes and volume. You can add and remove logical volumes from volume groups. You can add and remove physical volumes from volume groups, but those do have caveats.
Okay.
All right. So like, let's say that I'm just running a VM, right? And I can just allocate new disks to it, and let's just say I don't want to increase the size of it. Well, I can increase the size of the disk and then use LVM to grow and then manage that.
Yeah.
But I can also say, let's say I have a physical server, I have a SAN, right? For some reason I can't change the SAN's, like the allocation size or anything. So I hand the machine another disk and I say, here you go. I can take that other disk, pull it into the volume group, and then use that data.
Okay, so the volume group kind of is the glue that holds the logical volumes and the physical volumes together.
It's the pool.
Okay.
It's the resource pool. And you're allocating resources to the bottom and pulling resources out
Pulling it out of the top. All right.
Yes, sir.
Can you over-allocate like you can with btrfs?
I do not believe so. And even btrfs is not, I don't believe you can over allocate per
It's
se.
either that or CFS that you could create technically more volumes than you actually have size?
It's one of them.
Over allocation is usually a very specialized thing, and a lot of times it's going to be done inside of, like, say, VM technology. So you're going to be inside of
That's
like
where I knew it from.
VMware or something.
That's where I knew it from.
Yeah, VMware itself is actually what's out over allocating. It's not the file system that's doing it. The file system is going to report what's going on, and it gives you can do quotas. And so I can make a giant quota that's bigger than the files, the pool size, but it's still limited by the size of the pool. So it really depends on how you're looking at it. You can make quotas that are larger than the pool size, I believe, but that's not necessarily over quoting. If I use, like in ZFS, let's say I have 100, and we'll get to ZFS in a bit, but let's say I have a 100 meg pool, I can give you 50 meg, I can give you 50 meg, and I can give you 50 meg.
That's
That's
what I was.
a quota.
That's more.
You have a 50 meg quota.
Okay.
But if you and you use 50 megs, you have a 50 meg quota,
But you can't.
but you have
There's
0
no-
meg free.
There's no back.
Right.
Back.
Yeah. So that's probably a viewership.
Wrong
thing.
now.
Yeah. Well, it's a difference in terms kind of thing, but it's not over allocating per se. Whereas in VMware you can over allocate, where you can say
Oh yeah.
it's a similar type of thing. This VM has a 100 meg quota. There's only 50 megs on the disk. So once it hits 50 megs, you start having VMware crash. But
Right.
suffice to say, you can do that, and that is beneficial in different ways. But you have to make sure you're managing it. All right. So LUX. LUX is a encryption system inside of Linux. I don't remember what it stands for. But one thing that is very important about encryption systems, especially for your data, encryption systems encrypt data at rest, and at rest only. If I have a file system open that is encrypted, it's open, which means that anything that has access to the computer at the time that that file system is open has access to all of the data inside of that encrypted file system. This is useful. Let's say you have a laptop, right? And you turn off your laptop and you go home, or you're at the bar, you're doing some work, you turn off your laptop, you set it aside, you have a drink, and you forget your laptop. Nobody can access that data without your assistance. Now, one thing that I've noticed with a lot of people that use Macs and stuff, they don't turn off their laptop and put it to sleep.
Mm-hmm.
Well, guess what? Your data at rest encryption does not work if I can take your laptop, break into the operating system that is running, and now I just have all your data.
Mm-hmm.
So do understand that encryption is not a magic bullet. Yes?
So my screensaver's working, the encryption is
No
not.
encryption.
No, if your machine is on, your machine is, if it's on and it's past the boot sequence, you're basically open.
Think about it like this. You have a house. The house has a door lock. Whenever you're using the house, you have the door open. If you just leave without closing the door, anybody can walk in and take the shit out of the house.
So if you just suspend your computer, it's not gonna.
Nope.
Thank you.
No. Do a full power
It
off.
depends on how you suspend it, though. If you do a hibernate and then you have a, if you do a hibernate and then you have like a BIOS code, then the BIOS code would stop somebody. But then I can also just break into the BIOS, clear that code, get the operating system booted, break into the operating system, and get all your stuff. And it's a lot easier to do that crazy event of stuff than trying to decrypt your drive.
And you can do a live DD over network. So if you're on the network with somebody and you just close your computer and walk away, somebody can, if they have the right kind of access, be able to copy things through the network. And the encryption's not going to stop that.
Yeah,
Encryption is mostly for if somebody takes the hard drive out of the computer
Steals
and
your
goes and
computer
tries
or
to
whatever.
put it, or steals the whole computer, it's off. You try to get in that way.
It's data at rest. It protects data at rest, and that's all that it does. Well, it does two things. It protects data at rest, and it makes your hard drive performance garbage.
That's true.
So, there are a lot of times
Yeah.
there are hard drives and some laptops and different things that have a discrete chip that actually can assist with doing encryption, and it will offload doing that encryption on that chip. It's like a TPM chip.
Also, even with like, if you're just doing this pure CPU, like most CPU chipsets actually have assembly instructions for AES and stuff like that.
Right. So as long as you're doing
it's
something
pretty
that
high
it supports,
performance. Yeah.
it's pretty okay. You are going to have a performance hit, but it's not going to be like
Usually you can't even tell.
yeah. If you're running a virus scanner, it's probably going to do worse things to your hard drive than your encryption.
Yeah.
So to install this, you install a utility called Crypt Setup. So you do apt install Crypt Setup. One tip that you'll see on a lot of the Lux sites, it's a good idea for pretty much all encryption things, is to fill the drive with nothing but random. The reason that you do this is, let's say I have my 100 meg drive, I build my Lux onto it, I build my encrypted volume, I build a file system inside of that, and I fill it with 25 megs of like sensitive data, like tax reports and all this kind of stuff. If you grab that 100 meg, like you grab that drive, and it's like, oh, it's a 100 meg drive, cool, let me look at it, and it's 20 megs of garbage, and 80 megs of nothing.
Zero?
Guess what? I know where all the encrypted data is. I only need to break that, not the other 80 meg. And when you're talking about like a 2 terabyte drive, and you got like your 100 megs of tax data or whatever, guess what? Breaking 100 meg of encrypted data is way easier than breaking 2 terabytes of it.
Isn't that going to take a performance hit too for writing random values for the rest of the hard drive?
You have to do it initially.
Okay.
That's, yes, very much so, once.
Okay. Because I thought that there was a performance gain for writing zeros over all your blank space.
No.
No,
It's a right.
in actuality, doing this to an SSD can be very detrimental to it.
Yes, because it has a limited write cycle, right?
Well, it's limited write cycle, but also how the
Sure,
SSD
benefits
works,
Mm-hmm.
how they work in the back end of like doing the, what is it, F caching? I'm trying to remember the name of it, but basically it has
trim.
this, trimming. Trimming is hurt by this type of stuff.
Okay.
And so if you have an SSD, you're going to hurt your trimming, and when you trim, you're going to have to maybe even just retrim the
It's kind of a
drive.
garbage collection
Yeah.
process.
It's gonna hurt your performance. But doing that, like just filling the drive with data, like, hey, I got a terabyte SSD and I threw my entire Steam library on it. Oh, well, the performance with the shit. And it's just because the FS cache is just all garbaged up, and you need to trim your data and everything. SSDs are very interesting. Also, fun thing with SSDs, I believe, and you can let me know if this is not the case anymore, you can recover data from hard drives. You can't from SSDs. If I wipe the SSD with zeros, you're just done.
I can imagine, yeah.
You can't pull the data back off because there's no magnetic resonance
Yeah,
or
there's no
anything like that.
residue.
Like there might be stuff in cache or different things, but like if I just
Makes
take a
sense.
terabyte SSD and I have like an encrypted volume or even just data on there, and I decide that I don't want it to be like available to the next person down the line, and I just want to give it an SSD or like throw it away or something, I just zero it and I'm good. I think
Makes
that's
sense,
still the case, but
Yeah, the automatic trimming.
well, it's not even automatic trimming. It's just that when you set a zero on the SSD's
There's nothing
memory,
residual
it's
behind
just
it,
a
yeah.
zero.
Yeah, like with the forensics on the magnetic drive, they were looking at like the magnetic tracks that were getting left when the bit flipped and stuff like that.
Mhm.
And if you just zero a magnetic drive, a spinning drive, you can even just use software utilities that'll just read the drive again, and it was
Yeah.
oh, that was this.
This, yeah.
You have
It can still
to
recover some
DoD
things.
wipe is a 7-way
7 times.
wipe where it actually wipes it in different patterns. So 0, 1, random, 0, like E's, just like it does a couple of different patterns, and that kind of is able to wipe
Obscures
out
it over,
enough to where it's not really retrievable. But for SSDs, you just zero and you're good.
Yeah, so like Derek's boot nuke will do that, but and it's still free, but they've taken away all the certifications and verifications.
Really?
So if you're a corporation and you need a certification that that hard drive has been wiped, they won't provide it unless you buy their commercial version.
I mean, I get that.
No?
If you're using it as a corporation and you want it to be certified,
Yeah.
that's fine.
Yeah.
There's a program on Linux called Shred, I think.
Yeah?
Can
And
Bleach
wipe
bid
will do
do
it.
that?
Shred is a program that's like dband, but
Yeah.
I mean, bleach, I don't know, I know some people use what I call bleach bit, but
Yeah,
that's,
At least
Bleach
it can wipe your free space if I remember correctly.
yeah, but it's more of a programmatic thing.
Yeah, it's usually
Shred
more
actually
for-
takes a device and writes patterns to it.
Yeah.
And you can tell what patterns, so you can say zeros, ones. Pattern
That's what
blocking,
bleach
DOD,
did, but
whatever.
I'm not sure, I've never
Yeah.
used it.
So in here,
I don't
what I'm
know
gonna
if it
do
died.
is I'm gonna go ahead and I wanna make this a safe drive. I say DD in file is dev urandom. OF is dev mapper VG test dash LV test 01. Now you can look at it through a mapper or how it's mounted. There's multiple ways of looking at your volume or your logical volume. I also say BS equals 4 meg. That's not what we would say BS usually is. It's block size. That makes it faster. Whenever you're writing something in DD, it's going to write it in a minimum block size. If I tell it 4 meg, which I believe is the biggest DD you'll do, it writes 4 meg chunks. And so it writes a lot faster as opposed to like little tiny things. So it writes until it's out of space, gives you an error, no space left on device. It says, hey, I wrote 26 records in, 25 records out. So it tried to write the 26th one, wasn't able to, so it actually wrote 25 records. It's 105 megs copied, 72.3 megabytes per second. Cool. So now we have a device that's full of random. It's just random, all right? Cool. Now we want to make our crypt. So now we say crypt setup LUX format in that same device. All right, LUX format formats the drive to be encryptable. All right, it says, hey, it's going to overwrite data.
No, I know Dan's password.
Right. This will overwrite data. Are you sure? Capital uppercase, yes. All right, you want to be very sure. So type yes. Then it gives you a passphrase to enter. I put test. All right, so I say enter a passphrase, verify the passphrase, and then it's done. All right. Now I have a small disk, so it might have been faster than the big one, but whatever. All right. So now I want to actually do it. I want to do something with this. Right now, it doesn't show up. It's not a new device. I'm like, where is this thing? I have to actually open it. So I say crypt setup, LUX open. This guy, this is the device, and I want it to be named test 01 ENC. Okay? So at this point, I'm building a device. All right, so I've written, I have a encrypted device, but it's closed. I can't use it right now. I have to open it, unencrypting it live. And that's what the opening does. So I enter my passphrase, and that's our test pass again. And now, if I do an ls on dev mapper, I see my 2 logical volumes, I see a control thing, and there's our little test 01 ENC. So now it's a new device. All right, I can now make a file system. It's a writable device. So I can mkfs ext4 dev mapper test 01 ENC, and it writes a file system to it. And I can mount it. So I mount dev mapper test 01 ENC to mount, and there it is. In my approximately 100 meg device, it's got 83 megs available to it. So through formatting and different things, I've lost about 20 meg. And that's my encrypted device. Now it's open. I could write stuff to it if I wanted to, and then I need to close it. All right. Now you could set this up with your system where. I used to have this set up with my laptop where you log into the machine, you have a boot partition that's not encrypted. You can either have the root partition or just your home encrypted. As the machine boots up, it says, hey, there's an encrypted volume here. Give me your password. You have to put in your password, else it can't boot anymore, or it can't mount your home file system. Once you give it the password, it mounts that, it loads everything up, you're good, la-di-da, you run everything. Now you're shutting down your laptop, you shut down, it unmounts that, now it's encrypted again. I mean, it's encrypted on the disk all the time. It's just that the machine has the decryption certificate in memory, and it's decrypting it live and encrypting it back to the disk live. You can just access that material when it's running like that.
It's transparent to the user.
Right.
Yep.
Okay, so I unmount my mount. I say crypt setup LUX closed, test 01 ENC, and then that little device goes away. Any questions about encryption? Okay.
What encryption algorithm is LUX using?
It has a couple of different ones at least.
Those
I don't
options.
know what they are off the top of my head, but
Okay.
there's different ways of doing it. If you want yours to be faster or safer or particular ones, you can do that.
The options in there.
There are options.
Okay,
Yes, there's a lot of different options you can do that. There's some
Double rot 13.
very good material on how to do all that stuff. What's that?
Double rot 13.
Right. Very safe. The safest. All right, so file systems. There's a lot of file systems in Linux. In Windows, you get like 2. In Mac, you get 2. In Linux, you get like 50. It's ridiculous, and it's fantastic. I love file systems. They're fun. There's really 2 camps of file system in Linux. There's OSS and non-OSS. OSS file systems are generally going to be housed inside of the kernel. They're actually, the code for the file system is written in the kernel a lot of times. Those get loaded whenever you build the kernel in a particular way, or build them as modules or whatever. That is a non-tainted kernel way of building file systems. They're very fast. They're right at the kernel layer. That's generally what you're going to want to go for. Non-OSS, so like NTFS, I think, FAT, I'm not sure if FAT is or not. EXFAT is not FOSS. Those, since they don't have the GPL, they're reverse engineered, but since they don't have a GPL stamp, like the full file system is not able to be loaded directly in the kernel, and so you can only load it in via a fuse file system, which is a user space, which is extremely inefficient, or tainting your kernel by building the file system module and then mounting it directly onto the kernel. I know that's a lot of taking, sorry. I should draw it in a picture or something. So basically, there's 3 ways of using a file system in Linux. There is direct, where the file system code is compiled directly into the monolithic kernel. Okay, that's generally what you don't want to use that. You need to use that for what you're booting from. So if you're booting your boot partition, where you're pulling your kernel and the initRD and all that kind of stuff, it has to be supported by grub and supported by the kernel. Once you load your initRD, your initial RAM disk, that has all of your modules and everything, then you can load what's the second stage, the modules. Modules inside of kernel, I didn't expect to be going in the kernel design. The modules, you have the monolithic kernel and you have the modules. The modules basically plug into the kernel using the module layer of the kernel. What it allows you to do is you can load and unload pieces of kernel code directly into the kernel while it's running. This is very advantageous in a couple of ways. One, let's say that I want to have all 50 of these along with a bunch of other file systems ready to use, but I don't want my kernel to be huge, so I make my kernel really small, but I put a whole bunch of modules out there. This is actually what I believe what Debian does. There's a whole ton of modules, but the kernel itself has only the bare minimum what it needs to have not like in itself. So the advantage of this is you load the kernel in the memory, it's small, and then you only load the modules you're going to use. So the system comes up and it's like, oh, I need to use ext4. Grabs the ext4 module, plugs it into Linux. Ta-da! Now I can do ext4. Great, and it's just as fast as if it was compiled right in there. Let's say that I'm using ext4, and for some reason the kernel driver for ext4, has a bug or hiccup or whatever. Or like, let's say ZFS is a good example for this. Let's say I'm running ZFS or OpenZFS, and a new version of that comes out, and I want to restart. What I can do is I can compile that new version of the driver, unmount my ZFS volumes, unmount the module for ZFS, put the new module for ZFS in there, and then mount my ZFS volumes back up. And now I'm running the new version without having to restart the computer, which is great. So that's modules. And then Fuse, which is really the worst way of doing it. It's a great thing to have, but it's very inefficient. So if I want to use like exFAT or something and somebody hasn't written something like a kernel module for it, they've written a fuse module, what it does is it's a file system user space, and so it loads this stuff in, which is a fuse itself is a module into the kernel, and so you actually have a couple of steps in between your kernel and your file system handling. And since it's in user space is very slow compared to kernel space because of how it has to access the resources and everything. And so you can get more variety, but you're going to get much worse performance out of a fuse system. Any questions with that stuff? Mostly kernel. So you guys can read all that, it's fun. They call me crazy. So main file systems you're probably going to encounter. EXT series, the extended file system. It's EXT2, 3, and 4. I've never actually seen EXT1. I believe it exists. Maybe.
Aren't they up to 5 now?
No. EXT2 and EXT3 are the same file system, except EXT3 has a journal. You can mount an EXT3 file system as an EXT2 system. You can take an EXT2 system and add a journal to it and make it an EXT3 system. It's actually very nice. Back in the day, Windows had an EXT2 driver you could load into it. Yeah, and it was a third-party thing. Somebody made an EXT2 driver and you could kind of plug it in there. And so I could take so Linux, I could have my EXT3 file system, which was the major file system back then. I could mount it on my Windows box. I could do stuff, unmount it, and then load it back into the Linux box, and then I would just tell the journal, like, hey, go ahead and just recheck, and it would rebuild the journal, and it'd be good again. So that was one thing, is I could basically flip-flop back and forth, which was kind of neat. EXT4 is an extent-based file system. It is different. You can upgrade it to EXT3 to a 4, but I don't think you can downgrade. It is kind of a rebuild and different stuff. You're going to see XFS sometimes. I think Red Hat was playing with XFS quite a bit. It's a great file system. It made Silicon Graphics back in '93. Very fast file system. It's got some positives and some negatives. I think you can grow it, but you can't shrink it. Some strange stuff like that, but it's a fantastic file system. btrfs, it kind of strives to be a GPL replacement of ZFS that loads directly into the Linux kernel. I really, really wanted to like it. I actually pasted the wrong thing right here, so this is the extended file system. But btrfs has a lot of really cool stuff in it. It's a pretty solid, it's a fairly solid file system. The problem is it's fairly solid. It has some problems. It has some fairly bad bugs. And most of the thing I wanted most from it was like ZFS's ability to kind of do RAID. Do not do RAID in btrfs. You are going to lose your data. It is experimental at this point still. Basically, if you lose power when it's trying to write something, it's irrecoverable. btrfs also didn't have, I don't know if they have it yet or not, but for a really long time, they had the utilities to build it and manage it, but none of the utilities to actually recover it. So if you ended up being in a bad space, you just had nothing. So definitely check out the Linux Foundation, or the kernel is where all the stuff for btrfs is being developed. Check out their site, about the current status of the different components of it and everything. So if you're going to use that, check out that before you use it. Make sure it comes in with your use case. Now, that being said, Red Hat does, I believe, use that now as their primary file system. That does attain to its stability, at least in a single file system type. But again, if whatever features you're going to it for, make sure that those are mature. But it is a great file system. RiserFS, it's a new age file system. Development's mostly stalled. Guy went to jail. ZFS, I actually put Zettabyte file system, and then I went onto the wiki page and I'm like, oh, well they backronym the word zettabyte file system onto it. And then they said, eh. And so it doesn't actually mean zettabyte file system. That's just a backgronym that they made at some point and then dropped. There's two types of ZFS, and I'll discuss that in a little while. One of the things that's really nice about btrfs and ZFS, one of the reasons that btrfs is made and pushed, is there's a lot of really cool things that ZFS does that btrfs is trying to do as well. There's a cow system, copy on the right, that allows you to do snapshotting, that allows you to do replication of data to different sites without a lot of effort. If I have I can build a snapshot system that says, all right, once a day, I want to have a snapshot. I want to keep that snapshot for a week. All right. Now, let's say that somebody came in and they got a virus, and it's one of those encryption locker viruses, right? And I noticed that the day it happens because all of our stuff disappears. Guess what? I can stop everything. I stop the snapshotting. I just drop the latest material. I revert to the latest snapshot. Boom, I'm good. Now I'm good, minus everything that happened today. But that's really powerful. All right, so that's coded right into the file system. Data validation. I can take a file and I can say, is this data good? The file system can actually handle that for me, which is really cool. One of the things that's very important about this is ZFS and btrfs are made for enterprise hardware. They are relying on the memory being accurate.
ECC.
You need to have ECC. I don't run ECC at my house. Server hardware is expensive.
Yeah, I was about to say.
It's playing with
ECC.
fire. Right? If my memory goes bad and the system doesn't notice it, which can happen, especially on hardware for desktops and stuff, I can introduce silently corruption into my file system directly. It's very bad. So you should be using ECC memory if you're using ZFS or btrfs.
A lot of it.
What's that?
I said and a lot of it.
Well, yeah, memory is fantastic, and we'll get to that. So the next thing is availability to do pooling and mdadm type of stuff. So you can do RAID, you can do pools, you can do what we talked about with mdadm, what we talked with LVM. You can do that with ZFS, and to a lesser extent with btrfs. Btrfs is trying to get to that point, but they still haven't really achieved it last time I looked. Now, if they've gotten to that, whoa, that's great. I'm going to be really happy when that happens. But they're still working on it. It's very complex, so I get that it takes a long time. Compression and deduplication. You can do things like inline compression, where you literally have a file system, and I have like a pool, a little bit off of that pool, like LVM would be, like VG and my LV, same type of thing. But this pool I have compression on. This pool I have dedupe on. But for dedupe, don't turn it on. Don't use dedupe unless you know exactly what you're doing. Dedupe and ZFS is
Sounds great on the surface, and then implementation not so good.
it's unique. Basically, dedupe.
I've been burned by that one too.
For dedupe, what it does is it's deduplication of data. If I have 100 meg ISO of Debian, 6.0.1, and I have another 100 meg ISO of Debian in 6.0.1 in a different directory, and it's on the same file system, the dedupe system would allow me to use only 100 meg as opposed to 200 meg. So it's fantastic in thought, but in the implementation, the entire dedupe pool for ZFS at least resides in memory. So all of the dedupe pool resides in memory. Now you can do it on the disk, and if you run out of memory, that's what will happen, is all the dedupe pool is on the disk, it's just a lot faster in the memory. And every time you access the disk, it has to go to the dedupe pool information to understand where that data is and if it can write or read or do whatever. And so the faster your dedupe table is, the faster your disks are. And if you're pulling from the disk for the data and the dedupe tool, that's really, really bad. And I can tell you what, from personal experience, it's really, really bad. It goes from like, this thing's performing pretty good to, I can't access
I can't even get
anything.
logged in.
Like, I literally cannot pull up a directory listing. Like,
So what
It's very
happens if you go and upgrade one of those Debians and now everything is different than the other one?
no, it would just be, it
And then it
would,
just takes up twice as much space now,
Yeah.
right? Okay. I was just curious.
dedupe a lot of times is very useful for things like VM farms and
Mhm.
backups. Backups, a lot of times, if you're backing up full backups multiple times, you're gonna have, like, instead of one set of data, you're gonna have 16 sets of almost exactly the same data. And provided that you provide it to the system in a way like you're not encrypting it and then handing it to the system, because then dedupe does nothing for you. But if you just take this and you put it onto your backup system, and then you can have your backup system doing like encryption or
Same
whatever.
thing, if you end up
But-
tarballing it, it's useless again.
Right. So
And
you
then like we
put
also
your data.
said, you want ECCU memory for this
Yeah.
giant massive pool of memory you
Right.
need.
You use like the storage tech backend device with Veritech or Veritas or whatever, and you end up with like, here's 16 of the same type of backup, right?
Yeah.
Well, with dedupe, I can use up more or less
16th.
1/16 of the data size, which when disks are very expensive, awesome.
Yeah.
All right. You have to build your system to be able to take that.
But if you're a home gamer, it's probably better to actually just use some tools that can detect duplicate files and then just delete one and create a symbolic link.
Right. So yeah, if you're a home gamer like I am,
Don't
do
turn
it.
this
Just
off.
Don't do it. Just, and when you turn it on and you end up in a point where you can basically access your data, the only way to turn it off, at least in ZFS, is to turn it off on the file system, because you can turn it on and off. But all the data that's already there is, quote, deduplicated, so you have to move it from there to itself. And
how
since you
big
can't
is
really
storage
write,
service?
I mean, that's kind of, that's kind of bad.
And remember, the thing that it's stored on is the largest storage you have.
Right, like when I was working at my previous company, we had a device that was a ZFS device, and we had like 80 terabytes, and we hit the dedupe problem at like 50 terabytes or something, or like 40 terabytes, and they're just like, oh, we'll just move it. And literally we like turned it off, and we tried to move it, and it's just like, it's just moving at nothing. And it's just like, we have backups to do it, so we actually committed to just blowing the backups all away, blowing the entire pool away, rebuilding it without dedupes and slamming it back in. Because they sold it to us wrong. They sold it to us with 24 gigs of memory on an 80 terabyte shelf machine. And it's just like, no, like that thing maxes out at 144 gigs of memory, and you still probably shouldn't turn that on. Compression is fantastic. Use that. Turn that on. Compression's amazing, especially with LZ4. Super fast, almost no consequence to the processing of the data, but if you're compressing things like logs, holy crap, those compress great. So now your IOPS on your disk goes to the floor, and your space just opens right up. So minimal compression, great. I wouldn't turn on like the highest compression or anything like that. You can turn on very high compression. It is going to have a very significant impact to your IOPS. If you just leave it at the minimum compression, things that compress very well will compress, and things that don't compress very well
Oh well.
won't. So it's fun.
Don't do it.
Yeah, so minimum compression, fantastic, turn that on. Multi-device inclusion, you can put things in there like ZILs, ZFS intent logs, or ZFS cache, L2 arcs. What those do is an intent log, you have something come in that's trying to write, it writes it to the intent log, which is a ZFS, or an SSD. The SSD is very fast, okay, so it can take random reads and writes no problem. It then dumps that to the disk stack, okay? So think of it as just like a giant cache, okay? Now this is very, it's very resource intensive in certain ways, and some ways it'll help a lot, some ways it won't help at all, and some other ways it'll actually hurt your performance. So you have to really kind of see what your performance is, what you're trying to do, and what your intent is before you start approaching intent logs. Your L2 arcs, or your common log, is also kind of it's not going to hurt your performance, but unless you're pulling the same data over and over again, it's not really going to help your performance either. So if you're running like a VM farm and you have an image that you're pulling on 100 VMs and they're all pulling it all the time, that common read log will be fantastic because it's just right there. It's just like kicking it. But if you're not doing that kind of a workload, it's not really going to help. One of the really cool things about ZFS, I don't know if btrfs uses it or not, it uses the memory of the system for a read log. So it'll actually start using up your memory, as you were saying, like you want to have a lot of memory. In this particular case, yes, it'll actually use up all of the memory. It is configurable. But it'll use up all the memory except for 1 gig of memory. And then as processes use memory, it'll back off. But that's really cool. There's some pretty big pitfalls. When the file system's full, it's full. Congratulations. You can't delete anything. Because it's a copy on write. A delete is a copy. If you have no space, you can't copy anything, which means that you can't delete anything, which is bad. The way that you get around that is you add space. You delete stuff, and then you get rid of the space that you added. It's very bad. Again, this is an enterprise thing. Enterprises have monitoring on their file systems. They're not just filling their disk until
I don't know, man.
Yeah, well, if you know,
You're saying only if you hit 100%.
100%. If you run out of
But at
space,
50%, you can still delete things.
oh yeah,
Okay.
yeah, for sure.
Now, of course,
But you have to be careful. Let's say that you let's say you have a 100 gig. Heck, let's say you have a 100 terabyte array, right? And you use 60 terabytes of it, all right? Now that 60 terabytes, you have your snapshotting in place, and you have like a weekly snapshot. You have that 60 terabytes, all right?
Who does that?
Lots of people, corporations. So let's say that we have 60 terabytes. Why do you think Google and Amazon like you guys so much? Facebook. It's all that data, man. Facebook makes like $700 a year off of every person.
I was alive when people used paper to save stuff.
and at that point, they had different storage problems.
Right.
Primarily physical location.
Right, they're generating too much heat. So if you have a 100 terabyte array and you use 60 terabytes, this is where snapshotting gets weird. Let's say that I delete that 60 terabytes. Let's just say I delete that 60 terabytes. And I put a different 60 terabytes on there. Well, guess what? I just ran out of space.
Snapshot.
So I added 60 terabytes on 100 terabytes, so I have 40 terabytes free. Then I deleted 60 terabytes, and I put a different 60 terabytes of stuff on there. I'm out of space. I'm screwed.
120.
Because I used 120 terabytes of space because of the snapshots. When you delete something in a snapshot, because it's a copy on write, that's the whole copy on write concept. You're not deleting it until the snapshots get cleared. All right, so that data is still there. It's just not linked
How
to
many
the
levels
primary.
of snapshots do you
It depends on how you configure it. Like a default configuration of ZFS, I think does like 4 snapshots a minute, and then it clears after that, something like that. But you can configure it to whatever you want.
So you need like 5 times the memory you plan on using.
Well, it depends on how you're using the file system too. I mean, 60 terabytes of data is a lot. It's going to take a long time to load that in, unload it, load it back in. I mean, if you have like a day snapshot and you only have a gigabit connection to the thing or a 100 megabit connection to the thing, it might take you longer than the snapshots exist to load the next set of data, so you'd probably be fine. It really depends on your use case. Again, this is an enterprise level file system, so you have to take those things into consideration. It's not literally just using a disk. You're using pool, you're building multiple file systems, those things have a bunch of different stuff. Another pitfall is when you hit increasingly high amounts of fullness, so 85%, 92%, 94%, the kernel does different things to find free space. And it gets more and more aggressive about doing those things. once you hit 85%, or I think it's 85%. I know it's like 92 to 94% is the second stage of that, but I think 85 is the first stage of that. It gets much more aggressive about finding free space, and it gets a lot less efficient. So you don't want to hit above those numbers if you're running one of these file systems. Sometimes has problems with fragmentation depending on how you're using it. If I have, say, a stock app that's sitting there reading and writing on the disk, little tiny things all over the place, my fragmentation might go up. And so I might have to make a staging file system that's just ext4 that then loads data that I want to retain into the ZFS file system or something like that. ZFS and OpenZFS is a strange interaction. ZFS was made by Sun Microsystems with the CDDL license. It was bought by Oracle a number of years ago. Oracle then stopped the public release of that. OpenZFS is a branch of OpenSolaris, which broke off of Oracle when they closed everything out, and it took a divergent branch. So OpenZFS and ZFS are not the same thing. They're very similar. ZFS has continued to be produced and enhanced inside of Oracle. OpenZFS has been continuing to be produced and enhanced outside of Oracle, and so they may not be compatible anymore. I don't know anybody that tries to flip-flop between the two of them, but I use OpenZFS a lot at home. I use ZFS a lot at work. They play fairly nicely, similarly together. So you learn one, you kind of learn the other. btrfs could be not mature, many options, but it is it's pretty good in a lot of other ways. Did you have any other questions? Starting to lose steam here. So making a file system, you do makeFS.ext4. This is a symlink to, or it's not really a symlink. It's just it's a link to another program. It's going to be like makefs or makefs, and then with like different options and stuff. This is just basically a shortcut to it, and then you can add a bunch of options. So makefs that, it makes a file system. We mount that device to the mount point, and we do a df-h, and we can see that we have 100 meg mount. Now remember, our crypt one was like 82 meg free or something like that, or it was pretty close to that. You're not losing a lot of space doing encryption. And then if you run mount shows you all of the things that are mounted on the system currently, and I just grubbed for /mnt, and it gives me my mount options, and what type it is, all that kind of stuff. ZFS, we've kind of talked about that a lot, so I'm going to kind of walk through this. We already talked about pretty much all of that. Let's see. There's two major programs you're going to use. You're going to use zpool and ZFS for managing file systems. The pool is like VG and PV, and then this is like LV. You have the same type of RAID type of devices. None, which you don't just specify at all. It's kind of like a striper of JBOD. It'll actually kind of intelligently figure that out. Mirror is like RAID 1, RAID Z is like RAID 5, RAID Z2 is RAID 6, RAID Z3 is like RAID, well, let's call it 7, I don't know. But it's 3 parity disks. And you could do the same type of things where you're combining different types and stuff. Here I created a pool. I named it zpool. So I say zpool, create zpool. That's confusing. All right, this is the command. This is the name of the pool that I made. So zpool, create, pool name, RAID Z, which is a 5. Force, because they didn't have any information on there, so it was like, hey, are you sure you want to do this? So yeah, I said yes. And then E, F, and G. I say zpool status. It gives me the status of all the pools that are currently running. The pool, called zpool. I should have called it something else. Status online. It's not scanning anything. Here's its config. Everybody's online. Everybody. These are errors. So if you see numbers here, that's bad. It's also very helpful information. But and then like no data errors. That's again the checksumming, which is good. ZFS list. It's going to give me a list of all the ZFS file systems. I don't have any right now, so it's just got the zpool and the one mount point. So it actually has. This is a file system. I could write to that if I wanted to, but generally in the industry, we don't do that. Then you want to create some file systems, so you say ZFS create zpool test 1, ZFS create zpool test 2. Now, I didn't go over btrfs, I know I said I was going to do that with this presentation, but a lot of this stuff is very similar in btrfs, and you can find that information online very easily. Then on test 01 file system, I wanted compression to be on, which just does the minimum compression, or the default compression. I told it I want a quota of 40 meg, which is what we were talking about earlier. And then I go a list again, and it gives me my 3 things. This is the primary, and here's the 2 file systems I just made. File system 1, it's compressed, but it has a quota of 40 meg, so it has 40 megs available. Number 2 didn't have that, so it's got the entire free space available, so it's got 15.4 gigs available to it. If I want to see all of the options, there are a lot of options in the file system. I say ZFS get all, I could say ZFS get whatever, compression, whatever, it'll give me that specific one, but all, gives me all of them. And in the file system, it gives me a whole bunch of material about it, creation, how much is available, reference compression ratio, if it's mounted, quota, reservation, just a whole ton of stuff. We're not going to go through a lot of things. It even has, like, you can even do samba sharing and stuff like that, which is kind of crazy. I've never actually gotten that working right, but I've never really tried that hard. So yeah, there's that material, and then since the wiki exploded when I was writing it, here's the rest of it. And we're just going to go over quickly the NFS and ZFS, or NFS and samba. So NFS, are there any questions on ZFS? No? All right. One second. Really quickly, NFS and Samba are 2 different ways of sharing file systems over the network. NFS is network file system. Samba is a Linux part of building the CIFS file system, CIFS, or Common Internet File System that Microsoft, I believe, developed. NFS, I believe, was developed by Sun. They made a lot of cool stuff back in the day. If you want to do apt-get install NFS kernel server and NFS Common. NFS Common gives you your common utilities, like your client. NFS kernel server is the server. You start it with system.cutl status. Well, it starts on its own, but you use system.cutl to check the status of it. You configure it by editing the etc exports file. etc exports file says where, what mount you're sharing, who you're sharing it to, and options. In this case, I'm doing zpool test 01 to 10.10.10.0/24, so that entire subnet. I want it to be read-write. I want it to be asynchronous. There's synchronous and asynchronous, and we're not going to go into that. If you're curious, go look up. No sub-2 and no root squash, so the person on the other end can have root even though I'm not providing it to them necessarily. If I want to see the exports, I can do export fs minus v. I went past it, but the v would show nothing since there was nothing exported yet. I do -av for add for both. It exports it. I do v again. It shows me that I'm actually doing this one. And then if I wanted to do version 3 on Debian, I can edit this file, and inside of the comments it tells you how to do that. There's NFS stat, there a whole bunch of statistics and all kinds of cool stuff if you're trying to figure out what's going on with your system. And there's a lot of stuff you can do with that. For Samba, you want to install Samba and Samba client. Samba client's for the client, Samba's for the server. You get your status with SMBD. All right, and then to edit it, you have etc samba smb.conf. I would encourage you, if you're building a Samba server, to read the original one. It is very good. It's very well documented inside of the file. I just moved it over here because I wanted to make a very small, very efficient one. So I just moved that, so I still have the bridge so I can look at it. And then here's the one that I made. You have a work group, a server string, so whenever somebody talks to it, it says, hey, I'm, whatever. Server role is how the server actually runs. Host allow is who's allowed to talk to it, so I say 10.10.10 dot, which is that subnet, so anything that begins with 10.10.10 will be allowed, and 127 dot, which is localhost. Where to log, size of log, password backend, and if it has a DNS proxy, this is your core of your file serving. Say if anybody has a home and they have a password, they can do stuff to it, they can write, but they can't browse it. So
Is that password backend, is that the password that you need to access it?
that is the, I believe, the encryption that the password backend is kept in.
Okay.
I'll show you how the password works in a second. This is a specific share. The specific share is called public. I made a comment called user stuff. The path is zpool test 01. Valid users are user 1 and 2. Writable is yes. This is a special thing that's used very rarely, but I find it's useful from a home gamers type of standpoint. If say I have a couple of roommates, we want to share the same file server, but the permissions are kind of getting in our way. We don't really care. We just want it to be there. You can just have it force the user and group for every file that's written.
Oh, so the permissions are always going to be for user 1 and group 1?
Right. If you don't do that, then whoever logs in, it will become their permissions, which that's good most of the time. But from a home gamer standpoint, it's you want to these users have to exist for you to build the Samba stuff. And so here I said user add -m user 1, that adds the user on the system. And I say Samba password -a user 1, that's adding a password for Samba for that user. I make it a user, it says added user 01. Boom, I'm ready to go.
Is that stored in empty shadow or somewhere else?
It's the Samba password file. I don't know where it is. It's not shadow. It's not a system thing. It's a Samba thing.
Okay. Is that encrypted at all?
Well, it's probably that TPM SAM.
Whatever that is.
Yeah. You can look that up. I'm not sure, but that's probably
It's stored in a file, encrypted.
Right. It's probably a SAM file, which is what Windows does. To have these things take effect, specifically the config file change, you need to restart SMBD. So I service SMBD restart. And then if I want to look at statistics and different material like I would in NFS, I can do SMB status, and it shows me stuff about Samba. So that's it. Anybody have any questions?
So it's probably pretty basic. It's just something I haven't spent a long time doing. How do I get file systems like USB file systems to auto mount on boot?
That would be you have an auto FS thing that you can configure. I think a lot of times like different things will have it configured where you plug something in and it mounts it to like det or /media. That's a nomenclature of the auto FS system.
Okay.
I'm not sure how to do that offhand. I know if you have a specific one that you're trying to mount over and over again to a specific point, you can do that through UIDs.
UID?
So you have a UID and
Pardon?
so you would set up you would set the FS tab to have a particular UID, and then you can actually tell it where users can mount it, or I think there's like an auto mount flag or something in there. And if the users mount, you can like plug it in, and any user can just mount it or unmount it. And that's
It's for my server. Every time the server comes up, I want it to look for that hard drive and then auto mount it. So
that's very easy. If that drive is there all the time, what you do is you add any FS tab. You do UUID equals the UUID of that file system, and then your mount point, your mount options, and then probably 00 for you just don't have to do any checks or anything on that. And if you do the 00, if it's not there when it boots, the operating system will still come up. If you don't do 0, like if you do like 1, 2, it's like a type of checking and how essential it is to the file system or to the server's functioning. So the kernel will actually stop and be like, I can't continue.
Is the format of that line in FS tab the same as like mount? Like all the flags?
It's its own.
It's its own formatting
so,
and everything? Okay.
Just man the FS tab.
Man FS tab?
Yeah. But this is the FS tab for Debian here, and you can see that they're using UUIDs and part UUIDs, but they also have direct devices and stuff.
Okay.
And so you can specify a device, but since you're using a USB device, I would advise against that because other USB devices, let's say you have your server off, you have your one USB device plugged in there all the time, you plug another USB in device, you turn
That's
it
the other
on,
one.
and all of a sudden that USB device is detected first.
Mm.
Now the second one changes its allocation. If you have a UUID, it's always
Always
the
the
same.
same.
So
Okay.
that's why you would do that. So this is the device, the mount point, the type, the options, and then additional information for you for anything that's not the boot. You can see that boot is 1.2, root is 0.1. Everything else is 0.0.
Thank you.
My question was about, when I first was transitioning from Windows to Linux. And I had one drive had Windows on it, one drive had Linux on it, and I could read the Windows files from Linux, but not the other way around.
It's because Windows doesn't have drivers for the file systems that exist in Windows.
Okay, well, I found a piece of software that I could install that would let Windows read,
It had a driver.
yeah.
Yeah. So there was a driver in that piece of software that allowed it to read a particular file system that Windows didn't have a driver for.
So Windows just, now that, from what Keith had told me today, that Microsoft is getting into Linux, that,
They're not going to support all the file systems that Linux supports. Linux has built up that file system basis over like the last 30 years.
as far as Windows is concerned, there is no such thing as anything else but Windows. Is that kind of a,
That's
They're coming around.
for
Yeah, like
users,
that's-
I mean?
that's
I mean, I don't care now because I can read whatever I put on that old Windows.
right. So like let's say I have Windows and I have the ext2 file system on my Linux box like I used to a long time ago. I could read, if I used the, I think it was ext2 IFS or whatever program, it would install on there and I could read my ext2 or 3 system drive from Windows, and that was great. It was kind of a hack, but it would work. If I installed my system with btrfs on Linux, there's no way Windows would read it. So it just depends on what you're running on Linux to what is available in Windows.
Right.
Windows can read in TFS, FAT, FAT32, and EXFAT. I think that's it. We may have one or two others, but it's very...
I was just, you know, it's just an old thing
No,
that popped in my head from way back when. But to me, it was kind of like, they don't want to play with us.
Right. Well, I mean, it was... When you're dealing with something like Windows, so Windows is a dual thing. It's a consumer operating system, and it also has a server operating system on it. They want to support what they want to support, and they want to support that well. Linux is kind of we want to do neat stuff. So the corporate world has taken Linux and said, oh, it's a free Unix alternative, let's use that. And so it got very powerful and very good from like a lot of people putting a lot of material into it. But there's a lot of the hacker culture type of things in that as well, where it's just like, I really want to support a 45-year-old file system that nobody uses anymore. Let's write it for it. And like, it's not really like, it works well enough for the people that use it. But like, you know, who uses AFS or like the Acorn file system or anything like that? That's in the code. Like I can show it. Like I'm kind of done. But,
It's okay.
we can go into the kernel someday, and I'll show you all the file systems that it supports directly in the kernel. There's at least like 40 to 50 of them, if not more. So lots of cool stuff in the kernel. You can go and play around. There's fun little comments and stuff there too.
I'm going back to Windows,
I mean, I don't have any problems with that.
Wouldn't talk to you if you did.
All right, is there any other questions? Yes?
Which one would be, is ZFS something that would be good for a home user?
Sorry.
Or is that more for?
Depends on your usage. I use ZFS at home a lot.
Do you?
I use OpenZFS at home, it's great. But my system doesn't have ECC, so it is necessary, I'm taking that risk.
Okay.
Because you have
Even
a
if
risk
you don't
of,
turn on some of the fancier features of
it's a
OpenZFS?
core problem, because the way that ZFS, when ZFS holds its table of checksums and everything, it can hold it in memory, and if that table gets corrupted, then it could say, hey, there's corruption, and it tries to fix it, or like it fixes it to break it, you know, that kind of thing. And so you can have ZFS actually literally corrupting the file system because it's fixing things, that kind of stuff.
Okay.
So ZFS is fantastic. btrfs is very good. You do have to kind of watch out and kind of feature pick. For a long time, I was using mdadm RAID. So I was using RAID 6 with mdadm with btrfs on top of it. So I get the best of both worlds. You have a RAID that's stable, and I have btrfs, which has checksumming and snapshots and count file system and all that kind of stuff. And I combine those two technologies because btrfs is fantastic in some ways, but RAID is not one of them. mdadm is very fantastic in some ways, and being a pooling file system is not one of them. And so I took those two technologies, smushed them together, and got something that was almost as good as ZFS, but using two different disparate technologies.
All right.
So I mean, basically,
Last question.
RAID isn't where you just back up your whole data. RAID is for, you have a bunch of disks and you know they're gonna break every now and then, you just won't be able to replace.
Yes,
And
it's so
that's-
you don't have to rely on. RAID is a very, very, very good, almost good enough stand-in for backups. Backups have a very big thing over RAID though. If you lose your data,
It
like if
becomes
you
static.
accidentally delete your data or something, RAID's not going to help you from that. If your house burns down with the RAID array in it, you're not going to help you from that.
Lightning strikes your computer and burns
yeah.
both disks at the same time.
Right, like backups are very important. However, RAID provides you with a more resilient storage medium than single disk. That's what it really comes down to. If I have a mirror, RAID 5, RAID 6, it's going to be more resilient to failures than a single disk is going to be.
Thank you very much. So I hope you'll join us for the JaxLUG. It'll be held immediately following